all the best.
Hi guys, welcome to the bootcamp for Solidity hands-on training. Today being day 4 of the hands-on Solidity development. Now, if this is your first day and you've probably not caught up on the last 3 days that we've actually been doing training on the Solidity side, then a quick recap. On day 1, there was theoretical training on blockchain, the nitty-gritties of blockchain, how smart contracts really impact. That was taken by David. He is also an instructor on the same course in the University of Toronto. Day 2 and day 3, I have been managing, and I've been sort of helping the audience understand Solidity, play with smart contracts, deploy smart contracts on blockchain, and on that lines. Today being day 4, a little bit more advanced, a little bit more onto how we will be playing around with possibly more real-world contracts than anything else. Just as a small introduction, I have been into the blockchain space, developing smart contracts since 2017. Now, this year being today my 6th year in which I've been doing this thing. I've seen the ups and downs of this entire Web3 industry and sort of amassed a lot of decent experience, and thankfully have that position which I can just share my knowledge and bring you up to speed. Today, we are going to go through most of the stuff which is in a particular repository, the link of which, again, I will be sharing after the training in the Discord channel. This is basically a repository that we maintain on GitHub. Just quickly going over here, it's in our organization built by labs with the name tutorials. This is basically a lot of the smart contract that we sort of write about, including deployment, including testing and everything. Most of the stuff, even after this training, if you ever want to go to, just go to buildby.io, go to resources, and then go to tutorial. You'll find a lot of the material already available so that you can play around. For example, just learn how to code a decentralized hotel booking system, something like an Airbnb. As you'll see, we basically share code snippets and also explain what's happening inside the code so that you're able to not only understand what's happening, but also then play around with these smart contracts. Right. Okay. Coming back to this particular repository, today we're going to go through a particular folder, which is multi-contract tutorial. And the reason why this is named as multi-contract tutorial is because, first of all, obviously, it has multiple contracts. Second is that I've actually used the same repository in multiple sort of tutorials and sort of boot camps or trainings that I've done in different places, right? This starts with as simple as greeter contract or simple storage, and then goes into complicated contracts like the token contract, ERC1155, the NFT contract, and then one of the most complicated contracts, which is the multi-sig contract. The reason why it is multi-sig is sort of very simple. It sort of has its own interface, which is over here, iMultisig wallet.so, and also has other contracts, but it imports. And then you can imagine how different modular code essentially sort of plays around and how we go about with this thing. So without wasting too much of a time, I'm going to basically go through the greeter contract, then also the simple storage. And then we'll be essentially diving into how we're going to today deploy it and play around with it and do further things. Right. Now, before I go too much into depth, what I would love is that if you can just help me with in the comment section, either by putting a thumbs up or a thumbs down. Thumbs up representing that, yes, you are basically joining this call through or attending the session through your laptop, and you will have access to, you have access to VS Code, and you will be able to play around with it as we go along, or thumbs down if you're not be able to do, and then you'll be hopefully doing it later. So I'm just going to pause for 30 seconds, and then we're going to go through the instructions of how to play around today. Also, just to let you know, my colleague Chandan is also with me on the call, so he will be helping me a little bit, essentially managing a little bit on the YouTube side. In the last 3 sessions, I have also been just playing with a lot of YouTube, just watching the comment section, but today, unfortunately, I don't have access to that. And Chandan will be helping me in passing on either the questions that you have or whatever the status is. Right. So just going to go down into this particular contract. The greeter contract by definition or by very simplicity, if you understand, is obviously like a hello world kind of contract, right? It's obviously is going to just greet something. But we've gone ahead completely change a lot of things in this contract. It's no more just a greeter contract. Obviously, the idea is for you to see what's really happening. There is a particular contract that we've imported, which is known as hard at console smart contract. This particular contract is sort of mimics the what we typically use in JavaScript in React or other Node.js projects, right? Where we console log certain things. This contract essentially is, let's say, a helper contract. When we play with the hard at blockchain or any other test blockchain simulation environments, we will be able to see the output of console. This will not work in the main net or in the real blockchains because this works a little different. Right. So as we deploy the contract, the first thing that gets triggered is the console constructor contract, which basically just says this was deployed by who. Message.sender is a special key, or the message word over here is a special keyword over here. Message has a couple of more sort of sub variables that sort of carries. Message.sender, obviously the one who's the wallet address or the EOA, as they call it, the external wallet account. That is basically calling or triggering this function. Message.value being the value that is being sent along with it. I'll just stick to message.sender so that you understand. This one will basically console log that particular thing. We have certain function, which is basically just a sum, which unit a plus b, and return that. It says get my lucky number. That is basically going to return the lucky number that is stored against a particular address. And how that gets stored is basically by calling the function save my lucky number. It takes obviously my lucky number and then just saves it. As you will see, here is the line how it saves it. What we call the mapping. So I'll just quickly dive into over here to show you what mapping is. It's basically, you can think about of a key value kind of an object, right? The name of the mapping is owner to lucky number, or sort of just, it's a mapping creation. It will say that for every particular address, a particular number will be stored. And if I go down further, you will see these two other words over here. And these are honest function calls, actually. One is lucky number guard, the other one lucky number not zero. Both of them are over here with the keyword modifier. Modifier is, I would have, as I mentioned in my first day of training, this is a special function, which basically sort of puts a condition and then passes on the condition to whichever function it is depending on. So for example, this particular function, save my lucky number, uses these two modifiers. Lucky number guard being that, which is over here, saying that the if I have already saved a lucky number, then I can't save another one, because then the mapping will essentially kind of create a confusion. And the other one, that my lucky number cannot be zero. That's a condition I've put, and then it checks that and then calls the, or sort of executes the particular function. And then obviously I can just retrieve my get lucky number. And right, then I have the option to update my lucky number as well, which has another modifier should match previous lucky number, which is over here, which basically just checks whether the previous number that I've stored is the correct variable I'm passing, which means if I say that my lucky number is 10, but then I say, oh, it should change from 10 to 9, but this time I'm not saying I'm saying 9 to 9, then it basically throw in a, right. So that's the sort of quick rundown of the greeter contract. I'll also do a quick rundown of the simple storage, and then we'll start playing around with all out of these things. Here again, it's not sort of complicated. We basically storing a particular number, function store and function retrieve. These are straight away vanilla, so I'm not diving into too much. Again, a mapping, which is pretty much as you'll know. But now we have something more complicated. We are basically just adding people into a particular array, which is over here. And this is defined. So as you will see, the name of the array is people, but it has its own type, which is basically people with capital P. This is a struct. So what we're trying to say that this is an array of structs as we define it over here, and each struct has its own sort of characteristics or certain variables. One being what is my name, and the other being what is my lucky number. And that's pretty much it. That is what it does. Right. Now, to be able to play around much with this, what we will need is we'll obviously need a blockchain, and we'll need a lot of other things to be playing around with it. So what I'm going to do is I'm going to assist you with something what we even spoke about in the day 3 is basically go and change the hard hat config, and we'll define a network. Now, if you're following exactly the instructions, so the instructions are not that complicated. Just go to github.io/buildwarelabs/tutorials, and you will be able to see this repository. All you have to do is just clone it, right? And then from there on, you will be able to play along with me in this particular training. I'll kind of pause here for 10 seconds so that you're able to reach there. It's on the github.com buildwarelabs tutorials, or if you want, you can just go to buildware.io and just click this GitHub link. You'll be routed to the entire organization, and there just go to the repository tutorials. So what we're going to do is, assuming you have reached particular here and you're cloning it right now, the next thing that you have to do is just open the terminal and basically go to the folder, which is cd multi-contract tutorial, and do npm install or npm I. Since all my modules are already installed, this will not take too much time in my computer. It will take a little bit of time on yours. Once you have done that, what I will need you to do is, for simplicity purposes, just go to buildware.io, launch the application. And once you do that, you will be invited with a form that you might have to fill it up. Just quickly fill it up. And once you're done, you will be required to create a particular testnet. This will basically help you create a blockchain for yourself, and you will be able to deploy your contracts and run all the tests along with this one, and then be able to visit it tomorrow or day after, share it with your friends or share it with us over here through the Discord communication channel of a server that we have for Devsnest, and we can also assist you with this one. All you have to do is just come over here, choose the chain that you want to work from, select none, and then next, and then you should be good to go. Just said create buildware testnet. I am not going to create a testnet because for me, my testnet already exists, and hence I'm just going to use that one. So how we're going to go further is that I'm going to go to my hard hat config, and I need a couple of things. I need to basically update the URL, which is the networks object, which is for me to tell my framework, the hard hat framework of where my blockchain is. And I'm going to go through that. and also update what we call the verification tab. This is very simple too. All you have to do is just once you have created your own blockchain, just go to verify contracts. You'll see that this is the entire object, which is adding will bear as a network. So I'm just copying this object over here and then pasting it over here. And for the purpose of this verification, I'm going to just select this Etherscan object and again paste it. What this will do is now basically make sure that my project is connected with the particular blockchain that I'm currently running. In my particular case, I'm also going to do something what we call the accounts and then going to paste the mnemonic so that it is easier that I don't have to basically mnemonic. Yeah. So that I do not have to worry about making sure that my accounts have so and so funds or basically paste my private key over here and exposing. I'm just going to basically expose my mnemonic, which is anyways sort of test mnemonic, so it doesn't really matter. The reason why we do mnemonic is because now we are basically telling that our network or sort of project that these are the unlocked accounts that you can use for the purpose of this deployment and testing. And now for deploying either greeter or simple storage, I'm just going to go to scripts and run those particular scripts that we have. So as you see, there's a deploy greeter, or you will also see deploy simple storage. So what I'm going to do is npx hard@ run scripts deploy dash greeter. And then this will basically run that particular script and deploy my contract according to the configurations. Now, as you'll see, the script is already designed in a particular fashion that it will tell you that which account you're using to deploy the contract from. So this is my wallet address. It tells me that the contract has been deployed at this particular address, and it verifies the contract. Now, what really verification is, I'll also update you on that, because as you progress on the journey of the blockchain development, you will need to verify a lot of contracts. So this is our particular transaction, which is basically the deployment of the contract. As you'll see, contract deployed at 0x39 ends with 82C4, which is exactly what the script was mentioning. It was deployed using this address 0x8 and ends with FV4, which is over here as well. Now, if I click this particular address, which is the contract page, it will not only open the contract page, but it will also know the code which is of that particular contract. So let me click the contract page over here. And as you see, the read and write functions of the particular contract are now available. And I can play around or sort of call these functions on this blockchain. If I share this across with anyone, maybe with Chandan, or if you are seeing this, and if this testnet, I keep it live, then you will be able to come and play around with this contract. This is my particular private blockchain that exists that I can share it across with anyone, and so that we can all do the transaction solve. Now all I have to do is just connect to Web3. Just make sure that I'm at the same network. So it says built by the page, which is exactly the network that I need to be. And then I can call anything. So my, let's say lucky number is 99. I'm going to call the right function. It's going to open MetaMask. I'm going to confirm the transaction. I see the success is, the status is success, and this is a transaction which I've done. All I'm going to do is I'm going to go to read contract and also get my lucky number. Sorry. And I'm going to say owner to lucky number. I'm going to just basically copy my address from which I call this function, query it, and as you see, my lucky number is returned. I can obviously do multiple things, sort of A and B, and you get the point. Right. That's how we've just learned how to deploy a very simple contract like reader contract, deploy it on a test blockchain and do further things. Similarly, I'm going to now quickly for the purpose of catching you up on the other complicated contracts. What I'm going to do is going to run npx hard at test and the particular folder test. I'm going to run the simple storage test. Now, what have we done? We basically, I will also go through the test file so that it's easier for us to catch up on what really has happened. I first define a test file already, which deploys or certain runs a, deploys a transaction, deploys a contract, runs certain transactions, and also then checks whether the value that we're expecting from the smart contract is exactly the same, right? The only thing great about it is that I've done everything with my test blockchain, and hence I can obviously now with this visit those transactions and show you what exactly happened. But quickly running through my test script, which something similar to this I've already done on day 3. So just catch up on the day 3 video so that you understand largely on how we do the testing. Over here, I'm just saying before each, my apologies. My apologies, some issue with the place where I am. So I'll just kind of turn off my video. I'll have to, unfortunately. Right. So before each, we're basically just deploying the contract, and then we are actually storing some values. So this, as you see, we are saying that it should start with the favorite number 0. We are just basically checking the expected value, which is 0, and then checking whether it is 0. Similarly, now we're going to check whether the value is 7 and some more details. Now I'm going to go and quickly check on my Explorer if these exact transactions happened. And as you'll see, that 3 transactions were over here, which is basically about my test. Now, there is one quick small side note that I would like to highlight. If you're questioning in 13 days and what that is, this is something which is, let's say, a special feature of the build by testnet. We are able to advance the time in the blockchain to be able to test certain things which are dependent on time. And that's what I've done in this present case. I was actually testing some other things for which I had to advance the time of the blockchain. And hence, my blockchain is actually 13 days ahead of today. And that's why it says that these transactions will happen or sort of have a date time of 13 days. It's obviously just comparing the timestamp of my computer right now and saying that the date of these transactions are in 30 days. But some of them are actually in the history as well. Right. I'll just quickly open this particular transaction and to show you what this contract, because this is the contract created, and this contract was also this contract was actually in relation to simple storage, so you might not see everything. But what I'm going to do is I don't want to waste time, but essentially I could have just copy pasted the API over here so that you are able to see that the entire functions of this particular contract. Right. Now I'm going to exit this, and I'm going to also exit these 2 contracts, which are the creator and the simple storage one, and then go through the complicated one, which essentially most of the people will be playing around with, which is the token.sol. I'll pause over here for 30 seconds. If you have any questions, please drop into the comment section. And my colleague, Chandan, who's with me on the call, will just help me in passing on those questions to me. Chandan, just let me know if there's anything.
Yes.
Okay, I'll just proceed further with the token.sol. Now, this is a ERC20 contract, or you can think about the most of the contracts that you would have heard of, generally you would have heard of crypto or tokens or coins. Most of them are ERC20, which is a standard. The name of the standard was ERC20 and usually known as just the tokens. Now, this is a next step because it has just the contract, the name of the contract is token. And as you'll see, there are these two key things which actually start changing how or sort of advanced level development happens. First is you're saying it is IERC20, which is over here, IERC20. The I stands for interface, and that's the naming convention that developers just follow, which is basically an interface to the contract. The reason why an interface sort of exists, you can think about, is that if I have a smart contract which has complicated functions and algorithms and a lot of things that needs to be done, but now I do not want to really share up everything with the word. Point number one. Point number two is I may not, feel comfortable. And lastly, that people may not want to go through the complicated code to be able to just process or to be able to play around with that smart contract. And in that sense, interface comes handy. Interface is a special keyword, which basically defines the function name. Everything must be external. It cannot be internal over here, and tells you what it is going to return. That's it. The execution of the function, the entire logic over there, is not present. So if I have a very complicated contract, let's say contract bill pair or contract Devsnest, which has a lot of things, I will create the interface and share it with you. For your or scripting purposes or smart contract purposes, or for that matter, front end, you can just basically rely on the interface, import that and play around with it. You don't really need to know how the transaction or what is the logic of those functions. But once you define a particular interface, what you're setting is sort of a base level of what will be the function side my smart contract, what will be the parameters that will accept, and what will be the type of the return that this function will generate. Once that is done, your main contract will simply say, our token is IERC20, which means it's following the standard that is defined by this interface. Second is the level. Now here, safe math is being imported, and we specifically provide there is library which has its own function, right? We are using these two functions only for certain type of variable or certain type of characters you can think about inside my smart contract. So I'm saying using safe math for uint 256, which means all the uint or unsigned integers of 256 bytes will be impacted by these two additional functions: function sub, function add, subtraction, and addition. Everything else is just now play of the same contract. There are certain things that I'm defining exactly at the start of the contract in the storage of the contract. There are certain other things that I'm going to basically work from. Constructor defining the total, which is the total supply. If I'm now deploying this contract, and I'm saying what will be the total number of supply of these tokens, it can be 100, it can be 1,000, whatever it is. And I'm just going to put that over here, and it will create that total number of supply. And then so-called provide that balance to me who is deploying the contract. And then from there on, whatever happens is basically either transfer to someone. So if you give me, I can put a price off chain or on chain saying that I will transfer these tokens only when someone gives me $100 per token. If that is the case, if Chandan gives me $100, then I'll put Chandan's address over here and say, give him one token called this transfer functionality. Now, nothing complicated much to what we have talked about previously. It basically checks certain things that I have those many number of tokens and then updates the balance. And one of the things that balance is similar to last time is it's just a mapping. It is a mapping between two things, the address and the number of tokens that they own. The other one is allowed, which I'll come to quickly over here, which is based on the function transfer from. Now, what really happens is that assuming that we are multiple people who are doing a transaction, in this case, what will happen is I will give the permission to someone else to transfer tokens that I own to someone else, this person being the middleman over here. And hence, if I have to do that, let's say I have to give Chandan the approval to use 100 tokens that I own. not transferring the tokens, but only giving him the approval to so-called do that. I'll basically say that I'm giving Chandan, I'll just say my address and then give delegate, which is Chandan address, the permission to use my tokens. In some cases, you can go ahead and define how much the allowance will be. So you can actually say over here as uint 56 num tokens or maximum value, whatever. Should that be the case, then I'm saying that I'm only giving Chandan the ability to use only up to so much of my tokens. Now, what really happens is that this mapping stores that who is allowed how much. Essentially, my address, and then it values Chandan's address and how much that number is. Chandan can then later on call to transfer from functionality to be able to transfer from A to B. Now, similar to previously, I'm just going to go ahead and call the deployment of this particular contract. So I'm going to just move these in the side and also open up the deployment script real quick. Now, as you'll see, we just basically get the unlocked accounts. This will not work directly on the mainnet. So if you're trying to play around with the mainnet, the only thing that you will have to do for actual blockchain, which does not have any unlocked accounts, is you'll have to go and change the accounts from mnemonic to private key. And once you enter the private key, that will be the account for which you already control and which has the balance. So I'm saying get the unlocked accounts. Then once you do that, get my address, console log what my deploying address is. That's only for information purposes. You really don't need to. I'm getting the contract factory, which is token, and then I'm deploying that particular contract with the total supply as 1,000. Once it is deploying, I'm just verifying the contract. So let me do that very quick over here. npx hard at run scripts. Apologies, I'm not in the correct folder. cd multi contract tutorial. npx hard at run scripts deploy dash token, and running that script will basically do similar as previously. It's going to just log from which account I'm deploying and also provide me the address at which it is deployed and verify. I'm going to quickly just click this so that I'm able to go to that particular contract address directly. As you'll see, the Explorer shows that the contract name, which is token, this is the address which we just deployed at, and that is the exact code that you have just used to deploy. So here it shows this the entire token.sol, and since it imported the hard hat console, it shows that as well. And then I have what we call the contract area. For making it more easier, I'm going to check my balance, and I'm just going to copy this over here from which we deployed and paste it over here. And as you see, it says that the balance of this address is $1,000. Obviously, balance of my particular own address will be 0. Please. There is 0. Now, for the purpose of me writing and trying to do something else, all I will need to do is either import the private key of that particular address in my MetaMask so that I'm able to either transfer the function, or I can call some other functionalities just to check whether everything is sort of works. Transfer will fail because I do not have the balance, but just to check it, let me try to put an address. I'll say I'm transferring 100 tokens. Now, this will still pop up because it's an actual blockchain transaction. It'll say that, you know what, your like transaction will fail because you do not have the tokens. As you see, the status is failed, and that's a particular transaction hash. If I check that particular transaction, as it says, it's failed. We can now, in fact, check what really happened inside the transaction by decoding this input data, but that's for something for next time. Right. So I'm going to pause here for a 10-second again, so that I jump on to the next particular reference contract, so that you're able to play along with it. Okay. Now you'll go.
Hello, Deepish.
Yeah.
So we have a question.
Yeah.
So the question is that contracts written in Solidity runs on any blockchain or not?
Contracts written on Solidity will basically run on blockchains which are EVM compatible. EVM stands for Ethereum Virtual Machine. Basically, it's a processing engine which basically processes the Solidity code and sort of takes action on the function calls, input and output. There are other blockchains, for example, Cardano, Avalanche has something else, and then you have Zilliqa. These blockchains do not uh, uh, respect Solidity code or are not EVM compatible. There are some EVM compatible layers which actually run on them. For example, Cosmos is not a native EVM compatible blockchain, but it's a chain of chains, and there are a couple of chains which are EVM compatible, which run on the Cosmos SDK. Right. So all the Solidity code has to and will only run in EVM compatible blockchains. Right. Okay. Now sorry.
Yeah, we just have another question.
Okay.
Why can we use only constructor? Is there something similar to it?
No, essentially, right. Earlier versions of Solidity Solidity compiler, you had what we had is like this. Rather than constructor, you had basically a sorry. You had not the constructor, but you have function greeter, like this, right? And this would basically act for what we call the constructor. But now it has been renamed to constructor, which is basically a function that will run as soon as you deploy the contract. Having a constructor is not necessary. You can actually run this particular thing. So in fact, you know what, I'm just going to quickly do this. I've removed, let me just basically comment it out rather. Right, I've basically made sure that I'm not running the constructor function at all, but still this will still do the job. So what I'm going to do is, again, go open my terminal, cd multi-contract tutorials, and go to npx hard run scripts deploy dash greeter. And as you see, it still goes ahead and there's no problem. It actually first tells me that the compilation is successful, and then goes and deploys the contract, and this is the contract address, and will actually verify the contract as well. So there is no problem at all in that sense. However, if I do the same thing with token, then we'll have an issue, because the token contract actually has certain action to be taken at the time of deployment, which is setting up the total supply. What I can do is verify sort of change around here by saying function set total supply, TOTAL supply, and do the same thing. You into T6 as you get attacked. Most of the thing is already sort of taken care of. And I will basically also do balances, not balance off. Actually, just remove this thing here, do it here. You know what? I'm going to actually play around with this thing and just help you with a little bit. I'm basically removing the constructor, and also now I'm going to not put the message of sender. I'm going to actually put my MetaMask wallet address so that I'm able to show you the transfer functionality also. So I'm just going to say balance of this particular address has to be this one. So just to be sure, I will also do it just like this. Right, so I'm saying that the balance of this address has to be whatever you're setting so that I can then transfer it also. Okay. Now go back to the thing, run the same thing, but deploy token.js. Okay, we have deploying arguments. Yeah, right. I got an error because my deployment script expects me to give a value over here. Right. So I'm just saying deploy with nothing, just pure deployment. And there is no verifying, there is no constructor arguments. So remove that. And everything goes good. Good to go. There. There. Right. The contract is deployed and it's deployed over here. So I'm just going to go to that particular page. Now that is particular. I just go to actually for the purpose of this thing, I'm going to first check what is the total supply, and it should be 0 because we do not have a constructor. We have not done anything. So as you see, the value is 0. Literally, this contract is deployed with 0 token ever. And I'm going to just simply go and call the set total supply. And for easiness, I'm going to do 99999 and click the assign. I need to connect to my account. Done. And I think that would work. Yep, writing this thing. I'm basically initiating the transaction. And as it says, this is successful. It's done. And now if I check the balance of my address real quick. And my balance is 999. Similarly, the total supply has been increased to 999. Now I'm going to also do a particular transfer function so that it's easier. So understand the last one which failed. So basically just take the address, copy it, go back to the first one, say transfer to this one, a balance of 101. Write function. And the transaction is a success. To make it again, just to complete the loop, go to read again, just go check the balance of that particular address, and it is 101. Right. So you not only don't need a constructor, you can actually think about how you can rearrange your contract or rewrite your contract, but you still have to do some things either at the time of deployment of the contract or outside. Now, if I have to really deploy this on the mainnet, what I will not do is go to my token and make sure that my set total supply is basically set to public, which is a security risk if you think about, because as soon as I deploy, anyone can call this function, which might cause a pain because I might not want to set the total supply to be this. I might want to set the total supply something else. So what I can do is actually do a modifier, right? There are multiple ways I could, but for simplicity purposes, I'm going to just say modifier only me, and this will basically require message dot sender is equal to this. Actually, hopefully this actually just did it. Did it just do that? Yes, correct. And I am going to basically complete it with the entire thing. Now, it's not really, I think, a formal way how in which I think the Ethereum Foundation provides, but I was reading somewhere. For simplicity, you can understand what modifier really does is basically takes that particular code and puts it in the blank, right? So it basically puts the request statement and then follows this thing. So what I'm going to do is I'm going to say it's only me. Now, if I were to deploy this particular contract, what essentially I'm making sure that only and only this particular address can call this function set total supply. So if I don't call it, no one else will be able to call it, which will never have thus a total supply modification of this contract. Right. Any other questions, Chandan sir?
No.
Cool. Okay. Now we'll go into the next this thing, which is the NFT contract, which is over here, the artwork. Right. Okay. ERC20 is for what they call the normal token or the fungible tokens. I will not dive too much into fungible and non-fungible, but the only difference is that if every dollar is the same, they're all fungible. But if on a dollar that I own, let's say Barack Obama is signed, then I can go and say that this is unique to every other dollar note that has been printed, and hence this commands extra value. That is what NFT or non-fungible token is. The standard is 721 for that, and hence you will see most of the NFT contracts to say that they are 721, right? Similar to a token contract exam. There's nothing complicated. There's nothing such a huge difference between a token and an ERC 721, except the fact that this time, even though you might or might not have a total supply, that is different. But this time, every token has its own ID, and that ID is then linked to a particular address. That's largely about it. So if I say over here, I'm going to call the mint function. So I'm going to basically say that mint an NFT, and I'm going to provide a particular URI. Now, what this is basically like a URL, but we call it the unique resource identifier, where the metadata about a token is stored. You can choose to have your own NFT without having a URI. You don't really need to have it. It's just one, it's sort of where you're storing certain details. All the NFTs that you see in the world, which are basically either the Bored Ape or the fancy monkeys or the fancy dolphins, that particular data of how they look, the color, the skin, so much other things, may or may not be stored on chain. And if they are not stored on chain, they're stored offshore or outside the blockchain. And for that purposes, the URI comes helpful. This is just telling a particular third party that for every single token, I will tell you exactly where the metadata is stored. So when I say the mint function, which is me who's doing that thing, I will basically say mint a particular token to my address, message.sender. Here's the statement. And this will automatically do the token counter itself, right? It basically compute and sort of create an ID. And then it'll basically create a connection between the token counter, which is token ID number 1, token ID number 2, so on and so forth, with that URI. And this URI, as I mentioned, is just a place in which you can store the metadata. OpenSea, which is a NFT marketplace, reads the token or reads the metadata about a token based on its token URI. Right? So that's largely the difference. Everything around that is almost the same, nothing really that different. For example, setting a token URI, we'll obviously have to check whether the token does exist or does not exist. Token URI itself, which is basically just retrieving the token URI and just showing it in the front end. And then you can have transfer from and all. I think why they are not out here is very simple, because I've imported the actual standard of what is defined by the OpenSub link. Here, all the functions, mappings, and everything exist. I'm just importing them in my contract, what I call the artwork contract. So the balance of the transfer, everything you see is already there in that particular standard. The name, the symbol, so on and so forth. And just 1 second. Now, there's one thing which I'll just highlight you. This constructor says that I'm going to give a name and I'm going to give a symbol, again, very similar again for ERC20. The other one, I had already stored it inside the base definition of those variables. Here, I'm passing them as variables inside the constructor functions. They are then being passed on to the other contract of or the constructor of the other contract, ERC721, as name and symbol, and then getting stored. And if I show you the constructor function of the 721, it's basically a name will be passed and a symbol will be passed, and they will be stored for reference to the storage, which is over here. Now, the fact that they are private, which means that only through a particular function, we'll be able to retrieve them. So, for example, I have a function which says just keep me the symbol, and will basically then return the symbol. I don't have a direct access to this particular storage slot over here. Right. So quickly going over here, npx hard run scripts, and it will be deploy -artwork, and now we will be deploying the contract. These are some compilation warnings, and now it's getting deployed. Again, just tells me which this thing it is. The deployment script, by the way, has already been modified to provide some definite basic name and variable. You are free to change it. You can basically call it, Devsnest or Buildware or whatever you feel comfortable with the name, and then go ahead and do that. We've basically set the standard for you to just import and start running them. As you say, the contract is already deployed and is also being verified. I will also show you the impact of deploying a contract without verifying, so that you have an understanding over there. How does it impact us? And here I'm just waiting for the contract to get, there it is. I go and now read the contract and check the name, it's artwork. And if I check the symbol, it's ART, the one that we deployed. Now what I'm going to do is just modify this particular script so that we do not verify the contract and show you what really has happened. So see clear, again deploying the same contract, but this time it will not verify the contract. Right. So it just for some reason my script is now not even telling me where this contract is got deployed, which is okay. Interestingly, yep, I'm not logging the address, but that's okay. That doesn't matter. I can just go into the blockchain and check it. So I'm going to take this address, paste it over here so that I find the last transaction was executed. I can go to our transactions over check that, but it's actually more easier for me to check it inside this particular address page. Take the transaction, last contract that's created over here. I'm going to click it. I'm going to go to this contract page. Right. Now, as you see, the Explorer tells you that it is a contract. That's it. It does not, unfortunately, tell you anything more. It does not give you the read functionality, the write functionality. It just tells you that we know it is a contract, but we do not have either the ABI or the bytecode for us to understand what this is. There are multiple ways in we sort of verify the contract so that we can play around with this thing. The best way is to do it in the way we've already done it inside the script. Just run a particular verification script and your job will be done. Obviously, for making it a little easier for all the developers, we have the ability to submit the ABI directly, and I can still sort of play around with it. So I'll just quickly go to artwork, go to artwork.json, copy the entire ABI, and paste it over here, and then do a submit. And because I just submitted the ABI, Buildware only helps you with this much, that it trusts or believes that you provided the correct ABI and just provides you with the read and write functionality of that particular contract. Buildware will now, unfortunately, has not been able to verify whether the bytecode is exactly the same, which means you've verified with the correct code. Because it's a test network, because it's your private test network, you're free to basically easily deploy, change code, and play around with it. Right now, if I quickly check, the same thing happens. The name is artwork, and the symbol is also AR, because all I did change was the bytecode non-verification. If I do a hard refresh of the page, I will basically come back to the same state of my contract just showing nothing available. Right. So again, pausing over here for 10 seconds. If you have any questions, please do let me know.
Igresh, sir, we have a question.
Yep.
Yeah. What is the basic structure of a contract, and what are the requirements to be considered while writing efficient contracts?
Basic. So can you repeat that? Basic what?
Yeah. What is the basic structure of a contract?
Okay. Well, honestly, the only mandatory requirement for you to have in a contract is the, be the keyword contract, and you'll be I can have as simple as nothing inside the contract. But if you define any particular function, then you will have to define how that function has to be executed. Otherwise, it will be the compiler will start giving errors that it's an abstract contract. And if it is so, then define it as an abstract contract, which will needs to be ported to another contract and so forth. So there is no so-called super strict definition of the construct of the entire contract. You're free to play around with it or sort of write your own standards, so to say. So don't worry about that thing. General practice is that as you go along with, sort of work with organizations or dApps or sort of maybe audit those contracts to see them, you will see that most of the contracts follow something what they call the interface reporting definition. So a multi-sig wallet in this case, as you see, it has its own interface. This is very likely or like a standard that people follow because contracts these days are huge and have a lot of complications, right? And that's the reason why you will first provide an interface, which gives developers a starting point to understand what exactly is going to happen inside the smart contract. The other thing is that contracts should be modular as much as possible. Think of it as like React components, right? You try to have smaller pieces of code in different places so that it sort of does not impact you and at a whole. You just know where to play around with it. But you must know that one thing is that as complicated contract as this you see on the screen, when this gets deployed, the entire contract gets deployed as a whole, right? So it's not that I can go ahead and change one of these libraries or sort of functions called so on and so forth, right? They just become a whole. And then at some point of time, you'll come through what they call the flattening of smart contracts. And at some point of time, verification of smart contracts on Etherscan becomes problematic, and people do, sort of go through the option of submitting a flat file. A flat file basically just creates a entire one file of the entire smart contract. So these right now are sitting in different files and just be one single file, but with multiple contracts in it, so that you can see everything in just one file, what they call the flat file. Right. Chandan, there was a second part to that question also.
Yeah. What are the requirements to be considered while writing efficient contracts?
Okay. I think more important than efficient, I think security is the biggest risk, right? Like there's one big simple thing about blockchain. It's the fact that it's immutable, which means once the code that is deployed on the blockchain cannot be taken back, which means if you have a problem in your code, for example, the token contract I just talked about earlier, which I was playing around with, and I kind of didn't have this, modifier. This contract can now, the one that I already deployed, cannot be undone, which means I'm exposing this function for anyone to play around with and break, sort of cause me harm. So I think the most important that if you have to focus on what they call the secure contracts rather than efficient. The way we go into efficiency is how gas efficient your contract is, right? Which means when you write smart contracts, there are a lot of these tips that you'll hear about. For example, a simple tip like, if I have to, my compiler will give me an error, that this is more gas consuming compared to plus I. In both the cases, we're just incrementing the value by 1, but why I plus I is more cheaper in gas than I plus. What these gas do, right? They just basically execute, or sort of it's the price that you pay for the blockchain to process a particular function call. And you want to define a smart contract in a manner where everything is cheap to execute, right? But as I mentioned, as you work with any organization, your organization will request you that the contracts have to be secure first, gas efficient later, right? So first, make sure that everything is secure. There are no chances of what will otherwise be called as hacks, but basically unwanted transaction, unwanted results to pop up. Make sure that happens. Then you dive into how can I make this contract more efficient or gas efficient. For that, I think it's an experience. So you just have to go through a lot of contracts and figure it out how I can just bring down the gas requirements. Anything else, Chandan?
Yeah, we are also having a second question. How memory is managed? Do we have something similar to garbage collector?
We don't, right? We don't have any garbage collector in Solidity. And in that sense, we do not have the ability to play around with memory as freely as in other programming languages. Anything and everything related to memory and storage of the size of the contract matters. So the more storage heavy your contract is, the more gas consumed it's going to be mostly. So be very, very mindful of that. Yep. Okay, cool. So unfortunately, we run out of time, right? But I'll quickly run through with you at a very high level the ERC 1155 contract and the multi-sig. ERC 1155 is actually a culmination or sort of a conjunction or concatenation of two types of contract, both the 721 and the ERC 20. This is one contract in which you have your fungible tokens and non-fungible tokens inside it itself. So you can think of a larger basket being able to do both of them, right? They're not, and then each of them sort of has, its own functionality or sort of playing around with it. Yeah, as you play around with this thing, you'll sort of get a hang of it. ERC 1155 is obviously taking a lot of popularity because of games, which sort of need to have both the tokens, but having two separate contracts, smart contracts, neither two tokens was getting somewhere complicated, and hence 1155 is now taking some popularity over there, right? And then one of the other ones, which you may not see on a day-to-day basis, but sort of has a very huge impact on generally the Web3 ecosystem, is the multi-sig wallet. Basically, a multi-signature wallet or a sort of a joint bank account, if you can think about it. In this one, the logic is that if I have a joint bank account with Chandan and if I have to make a payment to Devsnest, what's going to happen is that I'm going to propose a transaction, and then Chandan will review the transaction, approve the transaction, and then one of us can execute the transaction. I alone will not be able to execute the transaction because of the joint bank account. And how it works is that, as you can see from the constructor, I'm going to provide the array of all the owners and check how many minimum people have to approve a transaction to go through, and then some cancel period. For example, I can say that I have 10 owners and we need a minimum of 6 people to approve the transaction. So 6 out of 10 is what we call it. This contract would become, and whenever a transaction is proposed by me, 5 other owners can approve the transaction. And once the 6th approval happens, any one of us, or for that matter, even the other 4 people who not approved it, can execute the transaction. Right. So this is a little bit complex, sort of complex structure that involves. It basically stores on chain all of those transactions. For example, I propose a transaction that's sort of stored on the chain, and so on and so forth. So this particular submit function is for me to submit a transaction that I want to be doing, approve, cancel, and execute, as I've just used the keywords. Now, in the approval or submission function, there are some things which are either simple, but some things which is complicated. The simple things is who I'm asking to pay or basically even do a particular transaction. It can be a smart contract address or a wallet address. The value, which is how much I want to transfer, it can be 0 or whatever. But this data is where a lot of complexity goes around. Now, in simple sense, this is the data or the bytecode which you will be sending to a particular smart contract so that that smart contract can take a particular action. What that is what I'll quickly just show it over here. Sorry, this contract deployed. And this is just my transaction, not this one. I was actually at that page. Yeah. Correct. Now, I don't remember, but this is likely to be an ERC20 contract that I deployed. And if I click this input data, you see this X code that is there. This is the bytecode. This will be very similar to, let's say, a transfer functionality. So imagine the other contract is being an ERC20 or a normal token contract, and I'm calling the function transfer from A to B, which means from my account to Chandan's account. It can be decoded for us to understand, but if it is not decoded, that's basically this is what's sitting on the blockchain. I actually sent this bytecode to this particular address, which is a smart contract, in this case, assuming this is an ERC20 contract. The bytecode, or essentially this particular hex, was decoded by the EVM and along with the code of the smart contract to people to understand what needs to be executed. And this particular bytecode is what goes into the other field, what we call the data. So imagine now this being a joint bank account. I want to actually say that transfer X number of tokens from this smart contract to, let's say, Devsnest smart contract. Then what we're going to say, the 2 will be the address of the smart contract or the ERC20, because we're telling that particular smart contract to update its balance, the mapping, which is the naming balances. I'll say 0 value because I'm not going to give any native tokens, but this bytecode will be that particular bytecode of that function call along with the variable. And then once everyone approves that and someone calls the execute, this is what it's going to do. Now, I'm pretty sure you would want to sort of play around with all of these things, get your hands more dirty with this thing, see how it's going to bad. And that is why I request you to go through these test files. Everything is sort of put over here already in test files with the correct explanation as much as possible, right? If you don't, obviously, please reach out to us at Prepare and we will help you in understanding them. But everything is written in the test file. All you have to do is basically, for the simplicity, just run, either you can run npx hard hat test, or you can run npx hard hat test and then go to a particular file that you want to run. For example, in this case, it could be multi-sig wallet, and all these transactions will be taken care of and executed in the Buildwares Explorer, and you will be able to see what needs to be done at what not. So you basically you can share a process X with us, and we'll be able to help you out with that. Right. So that's largely about everything about the sort of advanced level as much as possible of the bootcamp or hands-on dirty Solidity smartphone training. Your friend over here is the GitHub repository, so please go and access this repository, fork it as much as possible and run those transactions. The instructions of most of them on how to use it is already written on our website over here, buildware.io. Go to tutorial and you will see large everything written up. One of the most recent one that we just wrote was basically creating a rentable NFT using the new standard, which is there right now being in the market and being talked about a lot. 4907. This is an NFT contract, but this time I can rent it out to someone and basically make money on that. Cool. That's it, largely from my side. Chandan, any questions? Last questions that we should answer?
No.
No? Cool. Okay, guys. Thank you again. Please just go ahead and use the Discord server for Devsnest. Throw in your questions. We will share the link of this repository over there. Play around with all of this as much as possible, and don't hesitate to ask questions, and we'll be there. Happy to help. Thank you, and have a great day.